Hi everyone, welcome back to Operations Research. So this is our third course. We're talking about theory, and for today our topic would be a new one, network flow. So let's start with this case study as our motivation. There's a very famous company called P&G, and for the P&G company, pretty much is managing a lot of brands for consumer goods. Okay, so in the past, this company is worrying about one thing. It's about how to efficiently operate its supply chain, because this company has such a huge scale. It has hundreds of suppliers, a lot of plants, over 15 distribution centers, and more than 1,000 consumer zones, which means markets. Okay, so if we want to manage those item flows, we somehow need to formulate these supply networks. Okay, so somehow that means we have a lot of factories. All these factories have some routes to distribution centers, and they then distribute to all different markets. Somehow we need to make this kind of assignments or allocations efficient, so that we don't waste our time, waste our money to ship products from here to there, there to here, and don't make to consumers. So obviously a linear program or integer program helps, and this special structure of network transshipment must be considered. So obviously we have a successful story. The full story is here. If you are interested, please take a look. Somehow this study helped them save $200 million by restructuring the supply chain. Okay, so this kind of network optimization problems, I would say, is everywhere. So network flow models are pretty much one specific format of mathematical programs. These are used to study, for example, operations that are related to network transportation. We transport items on a network. So there are a lot of examples. When we want to from suppliers to factories, we may ship materials. From factories to distribution center or distributing centers, we may transport goods. Also to retail stores. If we are talking about passengers, railroads or flights, they are used to transport passengers, right? Data packets are routed through the internet. We still have this routing problem. We may send waters according to or through pipelines, and so on and so on. There are just too many things that you need to ship along those routes on a network. Okay, somehow we need to have some models to help us solve all these problems. So the unified model that we will introduce is called the minimum cost network flow model, which is abbreviated as MCNF. So this is particularly a very useful model in several reasons. So first, you will see that this MCNF problem is a special case of linear programs or integer programs. Okay, so somehow you will see a LP-like formulation. And what's even better is that we not only have an integer program or a linear program for MCNF. We will show you that MCNF has a very nice property, which says that once you formulate this problem and set all the variables to be integer, once you use branch and bound or use whatever method to solve it, you will always see the linear programming relaxation gives you integer solution directly. Okay, so somehow that means you don't need to pay the complexity, pay the waiting time, computation time for integer program. You just solve a linear program and then you get integer solutions directly. Okay, so later we will tell you why that is true, how it may be critical, and that somehow may help us convince you that MCNF is widely adapted because of this nice property. It not only helps us solve logistic problems, it also helps us solve inventory problem, project management problem, job assignment, facility location, and so on. Because we have this nice property, once we are able to formulate a problem into an MCNF, then solving it is just one single invocation of the linear programming or the simplex method. That would give us integer solution directly, binary solution directly, which is something we want in many cases. Okay, so later we will start our introduction.